Hello and welcome to my presentation on Engineering for Sustainability, which is a new study course in which we are teaching sustainability in a project-based degree program to create benefits for students, university and the region. I am kai.masuch, and together with dirk.nissing, I'm one of the course coordinators of this study course. Let me tell you who we are. We are the Rhein-Waal University of Applied Sciences. We were established in 2009. We are located at two campuses, one in Cleve, one in Camp-Lindford. The one we are located at with the study course is the one in Cleve you see behind me. And out of the 6,000 students, in the end, 56% are international students, creating a very diverse environment on campus. We have 4 interdisciplinary faculties, that is life sciences, that is society and economics, that is communication and environment, and where the study course is located at, that is Technology and Bionics. At the Faculty of Technology and Bionics, we made a survey of the region of employment of our graduates. So if you look at that picture, most of our students remain somewhere in Germany, and in the local region that is sadly only 18%. So we try to improve that. And for that one, we made a mission statement. That mission is also called One Mission, and that means that we think that teaching, research and transfer are a unified whole. Through close cooperation with industry and society, practical tasks will go directly into the teaching. And the involvement of students in the R&D process is representing an added value for industry and society. Also, students are resources. In 2022, the German Science Council released their recommendations for a sustainable approach to studying and teaching, and I will just cite 2 major statements out of that publication. That is, responsible personalities develop through freedom to make decisions and through guidance. And also, the curricular offerings should be oriented towards professional and academic socialization. From that on, we developed a functional specification for the study course. That is project orientation for future-oriented and sustainable goals. We have a competence orientation, teaching or subject expertise is guided by targeted competences. We have a strong paradigm shift, so the role of the academic staff changes from lecturers to academic mentors. We have a change in organizational structure. Our program is organized in centers, focusing respectively on academic disciplines, and we are following that one mission statement previously introduced to locally integrate research, transfer and teaching. And last but not least, we want to enjoy teaching the students, the lecturers and also the companies on site. So in consequence, we were restructuring our bachelor degree programs. We have now nature-inspired material, a generalized engineering study course, and what I'm focusing on here, engineering for sustainability, make the world a sustainable place, giving you a goal, a cause for your study. So let me introduce you to the structure of a new study program. But first, let's go into a typical one. In a typical one, the challenges at the beginning of your study are the toughest one. You have a very steep learning curve as shown here behind me with the blue curve. And while adjusting to the level of challenge at the university, also, if you're coming from another country, you have to arrange yourself with the culture. You have to learn the language and simply get your everyday life done. Then what is called enculturation also takes time, and we want to take that into account in our development and flatten that challenge at the beginning a little bit. Therefore, we have divided our study course into 3 blocks. At first, we have a real orientation phase, a complete semester that gives you the possibility to adapt to the new situation and get a grip on what it is like to become an engineer afterwards. So, after the first semester, we are going in the project phase. You are learning and working at projects directly and learning on the side also all the knowledge that you need to get that project accomplished. If you are through those 4 semesters of project, you go into a final phase in which you're doing an internship and also do your bachelor thesis. Let's have a closer look at the first semester. You are taking part in academic life directly. We are starting with onboarding and vocational orientation, in which we have field trips, in which we are making a code of conduct between the students, in which we already include a little bit of engineering, ethics, sustainability and so on, that you know what to expect in the next years. That is done in a block course. So 3 blocks of orientation After that, we go in directly in the second block, working in labs and technical hubs, in which you are involved already in all the technical installations on site with a hands-on mentality. After that, we take care of social and personal competences, in which you learn how to do work in a group, how to do a presentation, how to write a publication, and so on. After that, we go into what is really needed also for being an engineer, a little bit more of mathematics, called here strengthening of logical thinking, which is covering mostly your logical approach to solve technical problems. If we went through that, we go on the last 3-block course that is already having an independent group project in it, which you are solving together with your student colleagues. Our projects are organized in what is called Center of Knowledge. Let me first explain what this Center of Knowledge is. In a typical study course, you're learning in different modules, different subjects. For example, heat transfer is one of the modules you hear. Fluid mechanics, thermodynamics maybe, some kind of mathematics clearly also being separate modules. If you're an engineer in your working life in the end, and if you're working at a project, you need a little bit of all of those courses, but not necessarily every little detail that you have learned. So you are combining the knowledge that you learned in your study in your working life to a STEM that you need for solving the problems posed by a project. You're doing that on different levels. The better you get and the more complicated the real-life projects get, the more knowledge you need from those respective courses. But again, you're combining that by yourself to what you need for the project. And our idea was, why not turning that around? Why not starting with the competences you need to getting a project done? So we're starting directly in the second semester, that is the first project semester, with a project, taking a little bit of the knowledge of all of those leaves, combining that knowledge in what you need to solve the problems within that project. That is very close to what you're doing in your engineering life. So you are able to reproduce exactly the project work that is done in the industry. To give you a choice, we are not only having one center of knowledge, clearly we have at the moment 9 of those. That is, for example, biological transformation, that is business and entrepreneurship, that is digital product creation, engineering design, fundamental of science of mathematics, material strength and simulation, science communication, automation, engineering. Yeah. And from those you choose what you want to learn from and combine that by yourself into your individual study program. To get into a little bit more detail, that is an example of your individual study program. So you're choosing from those 9 centers in the second semester, being the first project semester, 5. And again, in that block structure. And also guided by what is called your personal mentor. That is one of the teaching staff members that help you to develop your individual course plan. After that semester and these 5 centers, you will see that some of those interest you more and maybe some less. So you choose focusing on your individual path 4 to further focus on in the next project semester. Narrowing that down afterwards into 3 and going into the details in the end in 2 individual centers. All of that, again, mentorized, guided by a personal mentor. While doing so, something has to change clearly, so what we don't do are typical lectures. The situation that you know in which one person speaks and a lot of other persons are passively just listening, that is not something that we do. We are changing that into a setting which is suited directly for solving project work, meaning that the lecturer becomes a mentor and that the listeners become actively involved into dealing with the project. So the students are already from the beginning project workers. We have different roles, clearly, as in every industrial project. For example, we have a coordinator, we have a specialist, and which role you take, that depends on you. That depends on your personal development, on your personal skills, on your skills that you want to evolve also. Which role you play is directly forging the path of your engineering career. Also clearly, in every project you have already multiple subgroups. So in one project, as stated before, from different centers, some people can be involved also in the same project. So meaning that we might have in one project process engineers, we have structural mechanic experts, we have bionics experts, automation specialists, all working together at one common project. For getting the projects done, we also went for a new weekly structure. So on Monday, Tuesday and Wednesday, we are working together on site from 8 a.m. to 5 p.m. On Thursday, you have the option for yourself to reflect on what you did. You have time on that day to do what a study is really all about. That is thinking by yourself, reading publications, maybe do a calculation. And after that, on Friday, you have the option to clarify the last questions to complete this week's work. Also, we have a new interior design concept for making that one mission in the projects happen. All center activities are taking place on the same floor. We have different learning environments. We have quiet rooms, we have rooms for small groups, we have rooms for a community forum, whatever is necessary to get that project work that you have done in that moment. We have that spatial diversity. Students find their own place for each learning activity. That is an integrated learning environment, so you're learning directly side by side with the technical installations inside that you are calculating and designing. And that also enables an as soon as possible cooperation for a successful project work in cooperation with the other centers being on the same floor. Let's summarize what we have in the study program. We start with an orientation semester in which you are finding out what type of engineer you want to be. We have a project semester in which you train your engineering skills deeper and deeper, that is, in terms of detail. And in the end, you go into your final semester with the internship and the bachelor thesis to finish successfully your study course. Let me show you our first feedback from a teaching analysis poll that we made for the onboarding module. And we asked the question, what do you learn most from this course? And the mentioned statements are the most agreed on statements. So, for example, it was pointed out that the constant discussion with the classmates is very important. That constantly expressing opinions and getting the feedback on them is also very beneficial. And last but not least, the small group and close contact with mentors allows students to quickly and objectively clear up doubts. And I think also from the pictures you can see what learning environment we have. Side by side, the teaching staff and students are learning and developing their own projects. Did you get hooked? If so, please stay in contact. Visit our website, look at the information material provided, and also go into a direct contact. You see the address behind me, which you can use for contacting me. And also, together with my mascot at that moment, let me thank you for attending and cite what Manuel Kant says: only plan and build facilities and machines according to the maxim that you would want to become a general law. Thanks very much for attending. See you next.